I want to take a little while here and introduce a new product that we brought to market. The product's called AminoShure-XL. And this is a timeline of Balchem's history with rumen-protected lysine. We introduced our original product, AminoShure-L, at World Dairy Expo, October 2008. We launched that product at World Dairy Expo. We were working on a second version shortly after that. That was introduced at ADSA in 2011 at the New Orleans meeting. We actually pulled that product from the market. I'm going to talk a little bit about that here in a couple minutes. We pulled that product about 10 months later from the market. We've been working on this next version, AminoShure-XL, for 12 years. Lysine is not an easy nutrient to work with from a rumen protection standpoint. So those of you here in the U.S., we made the decision back in 2012 not to bring the original AminoShure-L back to market here in the U.S. We actually sold it internationally the whole time in certain countries. And we actually introduced AminoShure-XL back in October of last year. So this is the original AminoShure-L product that we brought to market in 2008. It's a 38% lysine content product, 64% lysine bioavailability. That was based off of work done in Mark Hannigan's lab at Virginia Tech. So if you do the math on that, the metabolizable lysine content of that product's 24.3%. And I just want to share a couple of studies that were done here to bring that original product to market back in 2008. This first study, pretty simple study, really just comparing 0, 30, or 60 grams per cow per day of AminoShure-L. All of these diets were methionine sufficient, so lysine would have been the first limiting amino acid in these studies. And if you look at the data here, dry matter intake, we saw a nice dry matter intake response, 2 to almost 3 pounds increase in dry matter intake, and a nice increase in milk yield, 5+ pounds increase in milk yield with the addition of lysine to these diets. There was no added benefit to basically doubling the dose. That 30-gram dose of AminoShure-L in this particular study was sufficient for these cows at the time. We did actually see a significant increase in milk fat percentage. Now, granted, you would be fired if you were a nutritionist if you had a 2.91 milk fat in your herd. That's very unacceptable, but that's what it was at the time. And we did get a significant increase in milk fat percent, certainly an increase in milk fat yield and milk protein yield with the lysine addition in that particular study. The second study was some work that was done. There were 4 treatments here. Again, all of these diets were methionine sufficient in this case. So there were 4 treatments here in this study. There was a positive control diet that was formulated with a high-quality blood meal. It was balanced to meet the lysine and histidine requirements of these cows. There was a negative control diet that had all of the blood meal removed from the diet. So this was a lower protein diet. That diet was about 0.75 percentage units lower in crude protein. So that negative control diet would have been deficient in lysine and histidine. The methionine was kept sufficient in this case. The third treatment was the negative control diet with a rumen-protected histidine added back to it. We have actually made rumen-protected histidine experimentally since 2008. It works really well in studies. It's just not economically viable right now. the raw histidine is still pretty expensive as an amino acid. The fourth treatment was the negative control diet with rumen-protected histidine and the AminoShure-XL added back. And this was a really nice proof of concept study. So when we removed the blood meal from the diet, making that diet then deficient metabolizable lysine and histidine, we lost 4.4 pounds of milk in those cows. When we added just the histidine back, we did not get any of the milk yield back. But when we added back both histidine and lysine, we regained all of the lost milk yield. We're right back to the positive control diet on a lower protein diet, and that's reflected in the milk urea nitrogens here. So very, very nice proof of concept study. So fast forward a few years here, we launched version 2, AminoShure-XL. It was still called AminoShure-XL. We didn't really change the name. We launched that in 2011 at ADSA. So that product was 52% lysine. The original product was 38. This is 52% lysine, so significantly higher in lysine content. We assumed, you know what happens when you assume. I was actually not working for Balchem at the time. I was a customer. I vividly remember this, though. So the assumption was it had the same bioavailability as the original product, 64% bioavailability. So much higher metabolizable lysine content, 33.25% metabolizable lysine. And as I told you earlier, we sold that product for 10 months into the market. And it actually did very well in the marketplace. This is how it was characterized in the CNCPS model. This was the letter that went out to customers. This was the end of May in 2012. Basically, we made the decision to remove the product from the market. What happened was we're getting more and more data back, in vivo data, on the bioavailability of this product, and it was not 64% lysine bioavailability. It was lower than that. So we pulled the product from the market. I am going to read part of this to you. So what are we going to do to make sure this never happens again? So we're working feverishly to make product improvements. It took 12 years, but that is a true statement. I've personally been involved with this. I've been with the company 11 years. I've personally worked on this for 10 years. We will reintroduce AminoShure only when we're convinced it meets our standards. And we commit to ensure every new product meets basic standards for room stable end caps, which is feed durability and stability. I'm going to share some of that data with you. Rumen protection and bioavailability animal performance. So I want to share some of that data with you. So we move from that now into the journey to make AminoShure-XL. So we've actually been presenting studies at the ADSA meetings for a number of years now. Actually, this was a JAM meeting, so the joint annual meeting actually existed when we started on this. We haven't had this for a number of years now. So this was some work that was done back in 2016. We were still prototyping at this point. So we tested 3 lysine prototypes, 5x5 Latin square in a repeated Latin square design, 10 multiparous cows. The diet was about 15 grams deficient metabolizable lysine in this case. We did that by removing some of the high quality blood meal. There was still some blood meal in the negative control diet, just a lower level. But that's how we created the lysine deficiency, was by removing some of that high quality blood meal. The diets, again, all these studies I'm going to show you, metabolizable methionine was sufficient in all these diets. And histidine was sufficient. We're really trying to make sure that lysine is the first limiting amino acid in this case. So to orient you quickly to this slide, so there's our negative control diet. So that's our lysine deficient diet. This would be our positive control diet with a higher level of blood meal in it. And these are the 3 lysine prototypes we were testing. And we saw a significant milk yield response in this case. So this lysine 1, we saw a 4.3 pound increase in milk yield over the negative control diet. The positive control diet kind of fell in the middle. These other 2 prototypes really did not work well. And if you look at milk fat yield, we actually saw a significant increase in milk fat yield with this lysine product over the positive control diet in that case. So obviously, lysine 1 is what became AminoShure-XL. So everything I'm going to show you forwards AminoShure-XL in this case. This next study was done at Virginia Tech in Mark Hannigan's lab. Little different design from that first study I just showed you out of the University of Delaware. We were actually looking at 3 different levels of feeding the AminoShure-XL, so that lysine 1 from the previous study, the 102%. So we were comparing this, in this case, to the AgPro-L product. So we had a negative control diet. Again, that was, in this case, 16 grams deficient metabolizable lysine, 5x5 Latin square, replicated. So this 102% level, that's basically the level of lysine that we fed in the Delaware study. We fed a much lower level and then an intermediate level of lysine. We did not see a milk yield response in this particular study. There were no differences in milk yield across the 5 treatments. What we did see was a significant linear dose response in milk protein percentage. This actually looks a lot like a typical rumen protected methionine response. So we saw a nice increase in milk protein percentage over the negative control diet, and this treatment was no different from the negative control diet. So you can see that linear response in milk protein percentage in that particular study. We also ran another study at the University of Tennessee. This study was designed very similarly to what we did with the Virginia Tech study that I just showed you. 3 different levels of AminoShure-XL again. In this case, it was a 15-gram deficit metabolizable lysine in the negative control diet. In this study, we actually did see a milk yield response again to the lysine supplementation. So significant milk yield response over the negative control diet in this case. If you looked at all 3 doses there, the average milk yield response over the negative control was 3.3 pounds per cow per day. The bioavailability work that we did, we chose to do this work with the stable isotope technique in Mark Hannigan's lab at Virginia Tech. We really liked this methodology. It's an in vivo methodology. You can use this for any amino acid. You could use it for any nutrient, for that matter. This particular technique has been published many times, originally back in 2008 out of Canada. The Hannigan lab has done a lot of work with this, I'd say over the last 7 to 8 years, really refining the technique. The stable isotopes are not inexpensive, so a lot of the work that's been done in the Hannigan lab is really trying to find out how small of a dose of the stable isotope do you need to dose to these cows to get accurate bioavailability numbers. These are the results of that work, this was presented at the ADSA meetings last year. So they measured a 64% lysine bioavailability with the AminoShure-XL product. That is the abstract that was presented last year at ADSA. The last piece of data I want to share with you, because we do a lot of work really looking at feed stability of our end caps. Our encapsulated products, they will not work on the farm if they can't withstand feed mixing in the feed mill and TMR mixing and TMR stability. So we do a lot of work looking at that. If you have ever heard me give talks on this before, there really are three pieces to this that we look at. There are three key things that we look at when we're either creating a brand new rumen protected product or improving an existing one. So obviously, the first thing is we want good ruminal stability. We're trying to get as much of this nutrient through the rumen intact as possible. We're trying to maximize intestinal release as well. So again, aiming for higher bioavailabilities. But the key step that's missing a lot of times is feed and mixing stability. These two metrics, we have pretty good benchtop techniques to estimate that before we go into animal studies. When we find good prototypes for ruminal stability and intestinal release, we immediately go into feed and mixing stability studies. If we fail there, we go back to the drawing board, basically. And then ultimately, we run the animal studies, like I just showed you, to show the biological response in the animal. So there previously have been some work done with rumen-protected lysine products. The first paper that was published was the Xi et al. Paper, published back in 2016. That was some work that was done at the Minor Institute. Published back in 2016. There was a second paper published back in 2019. This was a slightly modified technique here where we use unprotected lysine HCl as a control. So this particular work was presented at the ADSA meetings last summer as well. So we had, there was 8 different treatments here. So there was a negative control, TMR, where there's no rumen-protected lysine or unprotected lysine HCl added to the TMR. There was a positive control where we added unprotected lysine HCl to the TMR at a known level. We also looked at 5 different competitive RP lysine products that have been on the market, and the AminoShure-XL. And these were all running triplicate. So these are all the samples laid out there. And basically what we're doing with this technique is we're measuring how much lysine is lost from these encapsulates as they sit in the TMR over time. So we take an initial reading right after mixing into the TMR. So there's a 0-hour time point, 6, 12, and 24 hours to basically mimic 4x, 2x, or once a day feeding of a TMR. And these are the results of that study. So this is looking at lysine release from these products as they're basically just sitting in the TMR from anywhere from 0 to 24 hours. So in this case, high numbers are not good. This is release of lysine from the products into the TMR. So you can see there are a couple products here that at the 6-hour time point had over 70% release to the TMR. By 24 hours, one of those was up over 80% release. There are a couple products here that at 6 hours lost about 10% and lost anywhere from 20 to 25% of the lysine to the TMR after sitting for 24 hours. This product had very good TMR stability, the one in purple, but somewhere between 12 and 24 hours started to release to the TMR. And the orange line is the AminoShure-XL, which had very good stability out through 24 hours, sitting in the TMR. There's about a 9% release to the TMR after 24 hours. So as you can see, there are very major differences in TMR stability between some of these products. We also had an abstract at ADSA last year looking at rumen-protected choline products with very similar findings there as well. So this is a product, AminoShure-XL, our encapsulated lysine for dairy cows now. So we introduced this here in the US last October, as I said earlier. We've modeled it this way into the CNCPS model. So it's a 54% lysine product. The lysine bioavailability, I've modeled it 60%. We got a 64% number at, in the work at Virginia Tech. I tend to be a little conservative. I modeled it at 60, which gives us a metabolizable lysine content of 32.4%. So just to summarize here, AminoShure-XL, 54% lysine, 32.4% metabolizable lysine, excellent TMR stability, well-researched at leading universities, cost-effective, and we're a one-stop shop for your rumen-protected lysine and methionine needs. So with that, I want to wrap up. If you're interested in the product, just contact your Balchem representative.